Complete the last question on the.
Can somebody give me some graph paper?
I got you.
Can you give people extra
I
credit?
did give people extra credit if
I
they
got
got it
it.
right in your
Oh
grade
my
already.
God.
Wow, you ain't
So-
nice.
I'll get it out for you.
Thank
Okay,
you.
here
I
we
did
go.
really bad on that quiz.
3.7,
No.
evaluating determinants and applying Kramer's rule. Okay.
Framers.
Associated with each matrix is a real number called its determinant. So there's a number called the determinant when we deal with this, okay? The determinant of a matrix A is denoted by A or the absolute value of A. So your determinant is denoted by A or the absolute value of A. So if you see, if they're asking for what is the determinant A or what is the absolute value of A, they're asking for the determinant. We're gonna talk about how you get that, okay? In a 2x2 and a 3x3, I will not give you larger ones than a 2x2 or a 3x3 to do these with, okay? In a determinant of a matrix of a 2x2, the determinant of a 2x2 matrix is the difference of the products of the elements on the diagonals. So difference, products, elements, diagonals. So you are multiplying the diagonals together and then you are subtracting them from each other. So I always start in the left top corner, okay? And I'm doing A times D here, so you would get AD, and then you are going to subtract it from the determinant, and the next determinant that we subtract it from goes from the bottom left corner up, okay? So from C times B. So your determinant is AD minus CB. When we look at it with numbers, I think it gets easier, okay, and we'll talk about that in a second. In a 3x3, you have to do some work before you can do the determinant. There are two ways to do it. I will show you both ways. One way, to me, I guess maybe is the harder way, but I think it's easier because I see it that way. So I'm going to show you two ways. Whichever way you see it, I don't care which way you do it, okay? So the determinant on a 3x3, they take the absolute value of all these numbers, they put it in the absolute value sign, but you have to recopy the first two rows, or first two columns, okay? So I have A, D, G, B, E, H, C, F, I. I recopy those first two columns, A, D, G, B, E, H. When you are finding the determinant, once again, we start in the upper right corner and we multiply A times E times I to get that space. A times E times I. Then you have to add to it B times F times G. Then you have to add to it C times D times H. Now do you see why I write these out here?
Hold on.
We're going to do it with numbers, it's going to be easier.
Okay.
Okay, so you're multiplying the diagonals and you are adding them to every diagonal that you multiply together.
Okay.
Why did you add two columns, the first two columns?
Because if you don't, then you are going to do it a different way that I would show you, and you have to loop back around, and that might be confusing to you. So if you add these two columns here,
Oh, because you have to have three left.
yes, because you have to go diagonally across three.
So when
Does
you're
that make sense?
3x3, you just take the
You just
A
take the
column and the B
first,
column,
yes.
and then you put them.
And you put them there, and then you
C.
start.
So you can add those and then subtract it.
And so then you add all the diagonals that you multiply together this way, and then you are subtracting from it all the diagonals you multiplied together this way. Okay? Let's do it with numbers, because I think letters get very confusing in this situation, because there's A through I. And so, can I go to the next one and we do it with some numbers? You tell me, you copy, and then I'll wait.
Wait, so what we're doing with G and H?
Okay,
and I?
so, good question, you mean with
This is the first, like, G, like, that one, in red, like the G, H,
this,
and I,
G
yeah.
times E times C goes here, plus H times F times A, plus I times D times B is in here. So this gets added together, when you do the diagonals this way, they get added together first. Then, they get, these diagonals get added together, and the difference of those diagonals added together is your determinant. Okay, is the number that represents that matrix.
So, alright.
So are you adding the A plus B plus I, or are you multiplying?
You're multiplying A, E, and I, adding it to the diagonal of multiplication of B, F, G.
4, 3, 2, you do 5
Mul-
times 4 times 3,
yes.
but then you add it
and then you add it to the next one. So you're always going to multiply, if it's a 3 by 3, you're always gonna multiply 3, add it to 3 multiplied, add it to 3 multiplied, okay? If it's a 2 by 2, you're multiplying 2, and then you're just subtracting. 2 by 2s are super easy, okay? So, we get examples like this, a 2 by 2 and a 3 by 3. And I'm gonna show you 2 different ways to do this on the 3 by 3. Okay? On the 2 by 2, I don't even really need to do anything here. I'm going to come to 5 times 1, and what's 5 times 1? And then I'm going to subtract from it 12. Okay? So when you do 5 minus 12, you get what? Negative 7. Okay, I get negative 7. Now,
Why are you subtracting?
because to find the determinant, you have to take the difference of the diagonals. That's just it's the rule to figure out what the term of that number is.
Is our answer not written with them brackets around it?
Nope, your answer is literally negative 7. You're going to have some type of number as your answer.
So no brackets.
So no brackets. So this is my final answer right here, negative 7. Okay? When I am doing this one, what do I have to do first on a 3 by 3?
You would have to add the
Yes.
those two
First
columns.
So I'm going to say
Columns.
2, 4, 3, negative 1, 1, negative 4. Copy the first 2 columns. From here, I'm going to start here and I'm going to say 2 times 1 times negative 2. What's 2 times 1?
2,
And 2 times negative 2?
negative 4.
So I'm going to have negative 4 here in parentheses. Then I'm going to take negative 1 times 0 times 3. 0 plus 0. Then I'm going to take negative 3 times 4.
Negative.
Negative 12. Negative 12 times negative 4.
48.
Positive 48. And that's what goes inside of this one right here. From that, you're going to, I'm going to do it in the other one in black so that we can see it. I take 3 times negative 1 times negative 3. What's 3 times 1 times negative 3? Negative 9, right?
Yeah.
Okay. Negative 9.
Great enthusiasm.
Then you have negative 4, 0, and 2. And then you have negative 2, negative 4, and negative 1.
So we don't do nothing with that one right there?
You don't do anything with that one right there. These two right here will never be used a second time.
So wait.
So you do, or will never be used, period. So negative 2 and 4 is negative 8, and negative 8 times negative 1 is positive 8. Okay, so now I combine like terms on the inside. What's negative 4 and 48? 44, right? So then I have 44, and I have minus negative 1, right? Negative 9 and 8. So then I get 45. 45 is the determinant of that. Can I show you a different way to do it?
Yeah, but hold on. I ain't even wrote down the answer.
Okay.
Mrs. Spears,
Yes.
do you have chapstick?
I do.
Yes.
Can I have some?
Well, it's like this. Do you care?
Is it chapstick?
Yes, but it's
He
not
can put his
like
finger over it.
not like one you put your finger in. Actually, I
Oh,
do
you
have
gotta
one.
put your lips
I
on.
have this one. You want this one?
Sure. I don't care.
Okay. So here's the deal. If you want to do this a different way, you can. I can take this and do it straight from here. 2, 4, 3, right? Negative 1, 1,
There it is, 40.
negative 4, negative 3, 0, and negative 2. Is that what's in the bottom?
That was me.
Yes, and negative 2. Okay. You can also find the determinant of a 3 by 3 by doing a loop method.
Oh, that
Okay.
sounds hard already.
It starts off the same way. 2 times 1 times negative 2. Okay, so I get negative 4.
Look, camera.
Then
I'm sorry, 40.
you would come here, negative 1 times 0 times
Oh.
3.
Yeah, just erase that right
Okay.
now. We ain't doing that.
Negative.
First one was you.
The first one's
You
0.
ain't doing that. Just erase that off the board right now. Ain't nobody
Don't
doing
even
that.
finish it.
Ain't nobody doing that.
Negative 3 and then negative 4.
Mallory,
And then
stop
positive
arguing.
4.
Ain't nobody doing that.
No.
So I do it this way because then I don't have to rewrite anything, and it just, to me, I don't have to spend more time doing stuff. You get what I'm saying?
I'm so confused. Can you redo it?
No, no,
you
no.
do the first one. So I would do -1, 0, and 3, which gives me 0, and then I would do -3, -4, and 4, which would give me,
Bro, they're gonna get messed up. You're gonna be crossing up with something else.
and then you would come here and do 3, 1, -3.
Positively delightful.
And then you would come here and do -4, 0, 2.
Nah.
Okay.
Anyway.
And then you would come here and do -2, -1, and 4.
What if you loop the wrong one? Exactly.
So you can choose to do it whatever way you want. I think the first way is probably easier visually for people. Yes.
It doesn't come off.
So how do you want us to show our work? Like in like
Yeah, you're gonna have to show your work. I want you to rewrite the 2 columns out and show me that you're going like this.
No, I'm talking about like in the last section we had to do a bracket and we have to do that number plus that number, like you know what I'm talking about. Do we do the same thing for here, or can we just like multiply? You know?
Yeah, you just do what I did right here.
Okay.
You kinda like
You
the
would.
loop. Well, if you like the loop and it works for you, go for it.
Time.
Okay, it's up to you, cause like I said, people see it differently, so it's up to you. Okay, you still come out with the same result, you just have to
I hope that's it.
think a little.
Further right, even loops.
Okay,
Whoa.
so here's an exciting thing about this, okay, it's not a problem. What is the equation to find the area of a triangle? 1/2 base times height. Okay, now here's the cool thing. When we have a triangle on a coordinate plane, or when you're mapping something out, like you wanna travel from here to here to here, okay? Or even in nautical stuff, they use this type of stuff to figure out things every day, okay? To figure out the area of the space you traveled. An area of a triangle, you can use a determinant to find the area of a triangle whose vertices are points in a coordinate plane. So if you know 3 points in a coordinate plane, I can find the area of this triangle without having to find the base and the height. I can just use the coordinate system by finding the determinant. So the area of a triangle with vertices x1, y1, x2, y2, and x3, y3 are given like this. If you take the area, it's set equal to plus or minus 1/2. The reason plus or minus 1/2 is there is because area cannot be what? Negative. So if my determinant comes out negative, I have to multiply it by the -1/2. If my determinant comes out positive originally, I multiply it by the +1/2, okay? That's why that's there. Where you take your coordinate points x1, y1, x2, y2, x3, y3, and you line them up in 2 columns. The third column always is gonna have the number 1 straight down it, okay? And then I can set up a determinant to figure out what the area of that triangle is. So you have 3 coordinate points, x1, y1, x2, y2, x3, y3, 1, 1, 1. Which means I'm recopying my columns, which are my coordinate system, and I'm doing the crossing and doing all of that. We're going to practice one of these. So yeah, you want to always yield a positive value, that's why you have to choose if you want to plus or minus. I'm not, okay, good, okay. So yes, I always want to yield a positive value because it's area, so that's why I'm choosing plus or minus. But it's the same thing. Basically, the determinant is finding the area of that square, and so when I multiply it by the 1/2, I get that triangle, okay? So your determinant goes with a square, and to find the area of the triangle, I just divide it in 1/2 or multiply it by 1/2. You've already used them?
No.
Okay.
How do you know which one is x1 and y1?
Okay, so it doesn't matter. If I name this point x1, then that has to be y1. That's the only rule. Otherwise, I can put it this order, this order, this order. It doesn't matter, we're gonna come out with the same answer, okay? So it's up to you how you see that, but whatever you name as x1, that y has to be the one that goes with it, okay?
Why would multiplying by 1?
We put the 1 there as placeholders, those 3 ones you mean?
Yeah.
We put those as placeholders so that we can make this system work. Because if I multiply anything by 1, it's just itself, right?
Right.
So we put those there as placeholders so that we can find the determinant and find the square value. So we can set up a 3 by 3. Because when you have 3 points, you have to have a third column to do a determinant, okay? I can't do determinants in other sizes if they're not the same. They have to be like a 2 by 2, a 3 by 3. Okay, they have to have the same dimensions to do that, in this case. for finding area. Wait. Isabel. You're killing me, Smalls. I'm good. Okay.
Wait.
So then they give you like these word problems like this, okay? It's saying, off the coast of California lies a triangular region of the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting whatever bay this is to whatever island this is. And some other island. I can't say these words. So in this map, the coordinates are measured in miles, okay? So when you're answering, remember you're gonna answer in miles, okay? And it wants to know, use a determinant to estimate the area of this region. So if I'm setting up a determinant for this, what am I setting up? What points do you wanna name as x1, x?
Negative 140.
Okay, negative 1, 41's here, and then I put a 1. Then I'm gonna put 0, 0, and a 1. And then I'm gonna put 38, negative 43, and a. So now what do I have to do to finish this determinant out?
You do the crossy thing.
Okay, but first I'm going to copy
You copy the first two.
first two rows.
Yeah.
Negative 1, 41.
Got you.
0, 0, 38, negative 43.
Shut up, Calvin.
Okay, so I come now, crossy thing. What's negative 1 times 0 times 1? 0. 41 times 1 times 38.
Don't bite him.
So 41
Well.
times 38 is 1558. And then 1 times 0 times negative 43. I like when the zeros are in there. They make my life easier. Now, we come the other way. 38, 0, and 1. Tyler's all over that. Negative 43, 1, and negative 1. So that's gonna be a positive 43. And then 1, 0, and 41.
I'm sorry, bro. My head is naturally inflated.
So over here, I have 1558, right? And I have minus 43. Okay, 1558 minus 43 is 1515. Am I done?
No,
No.
Why not?
you gotta do that half.
Because this should have a plus or minus 1/2 out here. Am I going to divide it by a positive 1/2 or multiply by a negative 1/2? Positive. So I divide this by
If the number is
2
negative,
and you get
divide by negative,
Okay.
77.5, right?
Could you also divide that by 2?
Yeah,
Or-
that's what I did.
Oh, I see that.
And then you
Wait,
get
so-
757.5
Right.
miles.
Please don't.
That's it.
Yes, squared. Thank you, Mallory. Mallory remembers. Okay. So 757.5 miles squared is the region that those seals and those, whatever it was, sea lions are in, okay?
part the Red Sea.
So that
Miss
is
Beatles.
that portion. What?
So when do we know when we divide by negative?
If the determinant comes out to be a negative, then I have to multiply it by the negative half because
Because
when I'm
negative
dealing
times
with
negative.
area, it has to be positive.
Oh,
If you have a positive, you must do.
So the only time I'm multiplying my determinants or changing the answer of my determinants is when I'm finding area. Otherwise, the determinant we just did, if you, like we got -7 as the answer, that's the answer. Okay? Only when I'm dealing with area do I need something to be positive.
So we divided it by 2 for the area.
So we divide it by 2 because you're taking half, yes. Because it's not a square, it's a triangle.
That was louder than usual.
It was louder than usual.
Okay.
Okay, we are going to stop at determinant
Oh,
today.
good.
the Lord.
Thank you, Miss.
Bye, friends.
Cameras is so different.
And, YouTube.
Bye, YouTube.
Bye.